Why does this bolt exist? There's no threads on it, but it has a socket head. I'm going to try again to machine that piece from the other day, but here's the problem. This is a G-code simulator. Basically, it'll take G-code, which is the instructions for the CNC mill. And it will simulate them. Now, I want to cut out this stuff here, but all these other passes I don't care about. This is basically a face cut. This is basically to clean the face of the material to make it look nice when you're finished. But I don't want that, and it's going to take a lot of time on the mill. So what I might try and do is basically just sit there and watch the mill and then cancel it before it gets to that step. The story with the CNC mill is that we bought it 2 years ago, and since then pretty much no one's used it. There's a couple guys who are machinists by trade that know how to use this tool, and they use it sometimes, which is great. We exist to sort of tell stories like that. But we also exist to tell the story of somebody learning how to use a tool like this. And that's not happening. We haven't been able to figure out a good workflow, basically from getting a 3D model file to a finished part. We haven't been able to figure that out. There's a process there that involves taking the 3D model file, loading it into a program, and then having that program do what I'm calling G-code generation. I believe this is usually called CAM. In order to understand this, I think it's really important to understand what G-code is. G-code is a really old programming language, essentially, and it's used to program all sorts of machines, from 3D printers to CNC mills, CNC plasma cutters, and basically if it's a CNC tool, there's a really good chance that it uses G-code to command itself, or rather that you would create G-code programs that would command the machine. So this is the this is the software that we use to control our CNC mill. There's a couple of screens here that are important. This is the one where we would run our program, but this one is the one I want to show you now. So it gives a display of where exactly the machine is, and let me move this back a little bit so you can see. I can use these arrow keys down here to just move it around. So if I hit right arrow key, the table moves left, but effectively the mill moves to the right. If I go left, it'll go to the left, and then forward and back. So as I move this thing around, watch these numbers up here. This is really important. So if I go to the right, see how this X goes negative 1.1022? That means that the effective position of the end mill is now negative 1.1022 inches away from where it started. So if I move this back to the right, again the table's going to move to the left, but you can imagine that this is effectively moving to the right of the cutting surface. If I move it back to the right, I can move back to about 0. Same thing if I move the y-axis. You can see this number changing as I do it. Really all this tool cares about are those numbers. X, Y, and then Z positions, which is up and down. Let's write some G-code and then see how it affects the machine. And I think if we do this, it'll really help inform on what G-code is. If I go down here, I can just input commands in here, or rather input positions. So right now the machine is at X 0.5, Y 0.5. That means it's a ½ inch to the right and up from where it started. Now if I wanted to send it back to where its home is, I could say X 0.0, oops, gotta click in there, X 0.0, Y 0.0. Now if I type that and press enter, the machine will just go back to 0, 0. Let's try a different thing. If I type X 1.0, Y 0.0. So that's going to say move the X 1 inch to the right. So let's do enter. Cool, it moved 1 inch to the right. Those are 3 really simple commands. Now if you imagined thousands of those, in fact the project that I'm going to try and run right now is about 75,000 lines of coordinates like that. So here you can see I have this option, load G-code. So let's click that. and I'm going to go into a removable disk that I have. Oops. There's my thing, logo.gcode. I'm going to load that up. Okay. This is the meat of the program. Right here. X, negative 1.5, Y, 1.5, Z, 0.0924. If you apply what I just showed you, which is the idea that you can just type coordinates like that into the machine and it'll go there, you can start to understand what it's trying to do. It's just telling it places to go. This file is really, really long. It's, like I said, about 75,000 lines long. It's really, really big. But it's just full of lots and lots and lots and lots of commands like that. Go here, go here, go here, go here, go here, stuff like that. My problem is generating a file like that. It's really big, it can get really complicated. There's software to do it, but that software is difficult to use. So that's what I'm trying to learn right now. Here's something really important to the operation of this machine. Now I said that you can just give it coordinates, x, 5, y, 0.2, stuff like that, and the machine will go there. But in order for that to be useful, the machine has to have a reference for where 0 is. So it can't go plus 1 inch if it doesn't know where to go plus 1 inch from. That's where this comes into play. You can set those things here. So for my project, for what I'm about to do, I want this machine to be about in the center of where it can, the center of everything, the center of all of its axes. So I'm going to do that. Can also move this thing up and down, so I'm going to move that up to about halfway. Okay, now the machine is about right in the center of all of the places that it can move, which is where I want it to be. I can just click these buttons that say, okay, consider this to be 0. So all of your instructions reference them from this point. That's probably really loud, but this is what the machine will do while it's running, and it'll do this for a really long time. My program's working. Okay, we're going to turn the mill on. Everybody look out. Okay. Here's where I'm at with G-code. I've been trying to use Inkscape's G-code tools. I tried to learn Fusion 360. These are all, I'm sure, fantastic pieces of software that you can totally use to make stuff. But I think what I might enjoy more is just learning to write the G-code myself. So in looking, it looks like the file that I'm trying to create is nothing but straight lines and a couple of arcs, which is all stuff that I think I can program myself. So the next step in this project is basically that. It's going to be learning to input these coordinates myself and see if I can generate my own G-code file. I said that I tried Inkscape and it didn't work, and I tried Fusion 360 and it didn't work. These are both tools that people use, and it's not... I want to be clear when I say that the problem is with me. It's not with the tools. It's not that it's broken tools. It's that I'm not taking the time to learn how to use them properly. What I want to be careful of is falling into the trap where you blame the tools for not being able to solve the problem that you're trying to solve, instead of realizing that you just need to take the time to learn those tools. Inkscape and Fusion 360 certainly could do the project that I'm trying to do. One tool that I will blame is iMovie. I hate iMovie. I hate iMovie because it seems like Apple intentionally crippled it. Why can't I position audio with more than 100 milliseconds of precision? Like, it's just dumb. It just seems like they're trying to get me to buy something. Which, alright, I get it. Software can't be free. But it's still frustrating. Software can't be free. I say as somebody who uses Apache, MySQL, Linux, GNU, and Python every single day of my life.